Okay, so last time we left off by while we were discussing equations of motion, right? So we had these variables that we looked at, these quantities. We had displacement, time, velocities, and acceleration, and we wanted some equations that could link all these variables so that we can do calculations and predict what's going to happen next, right? So we have four of these equations, and these equations, first of all, are only valid for a straight line motion, which itself implies that there is a constant acceleration for that motion. So whatever journey that you're considering for the object that you're applying these equations of motion to, you should only be considering the part of the journey where the acceleration is constant. As soon as acceleration varies, these equations are no longer valid. So you can say that these equations are really a form of special case of some equations that are more generalized, but we'll not talk about those in this lecture. So we saw that we have these two equations of motion, which are pretty straightforward, and they come from the definition of the quantities that we have discussed so far. We have acceleration, which is the difference of velocities over time. So the change in velocity per unit time, which you can rearrange to get v is equal to u plus at, and that's your first equation of motion. The second equation of motion comes from the fact that, again, we know what velocity is, and velocity is just the average velocity is just the average displacement per unit time. So you can rearrange this equation such that you have average displacement is equal to average velocity times time. Now, the average velocity can be computed by considering an initial velocity of the particle and the final velocity of the particle, and then you have just two velocities, so you have to take the average of these two numbers. So it's from simple mathematics, you just add them and then divide by the total number, which is 2 in this case. And then you have times time. So you can, then this gives you an equation that S is equal to 1/2 times V plus U times T. And this is your second equation of motion. So these two were very basic. The other two, we're going to make use of these two and derive them. So before we proceed forward, any questions from the last lecture? Or
No,
from
sir.
anything that I have?
No, sir.
No questions? Okay. All right, so let's continue, right? So these are the two equations. Let's mark them. And okay, so you have this equation. I'll rewrite it again. So I'm going to derive third equation of motion. So you have v is equal to u plus a t. It is from this one, and then you have this thing. S is equal to v plus u over 2 times time. Now there's something that I can do in this equation. I'll take this first equation and put it in the second one. What does that mean? I'll replace the v in second equation by what is on the right hand side of the first equation. So this becomes S is equal to, so for v, I'll write u plus at. So it will be u plus at, and then you have again plus u over 2, and then all of this multiplied by time. Simplifying this equation, you get 2u plus at over 2 times time. Now, this equation is, again, it's completely valid, but you can clean this equation up a bit and write it as S is equal to, so you multiply this t with this one. So actually, I'll do it 2u t and then divide by 2 first term, then plus second term a t, and then outside you have t, so it becomes t squared, and then divided by 2. So you see that these two cancels and you're left with s is equal to ut plus half at squared. And this is the third equation of motion. Okay, so was that clear?
Yes, sir.
Yes, sir.
Okay. So now let's derive the final one. Okay, so well, there are multiple ways in which we can do this. So let's look at one of the ways. Again, we'll look at these equations. V is equal to u plus at, and s is equal to, let me say, u plus v, this one, right? U plus v over 2 times time. Now, what we can do is we can change this equation up a bit and write it as t is equal to. So everything else goes on the other side. So it becomes t is equal to v minus u over a, right? And then you just put this back in this one. So this is s is equal to u plus v over 2 times v minus u over a, right? And now if you combine these things, you get u plus v times v minus u divided by 2a. So you can write this as v plus u, so that the first variable is the same in both of these terms. And now this what do you call this, numerator, right? So in the numerator, whatever I have from mathematics, this is just equal to this difference of the square of both of these terms, v squared minus u squared. Because if you know from mathematics, you learned that this thing v squared minus u squared can be expanded as v minus u times v plus u. And you can call it an identity, but it's just coming from the mathematics of multiplying these two terms, and you see that indeed that they are this thing. So this is what you have, and then here you'll have 2a. So rearrange this equation as 2as. So you just brought 2a to the other side, and this is v squared minus u squared, right? So this is then the final equation of motion, the fourth one. So any questions from this? Was this clear?
No question, sir.
Okay, all right. So can you tell me why do I need all these equations? Like, why do I need 4 equations? I mean, was one just not enough? Why is it that we derived 4 of these equations? Any idea?
Sir, because time came in here, came in here.
Yeah, exactly, right. So it's because of the fact that there are some quantities that you might not know, and in some of the equations those quantities are not even required. So for example, in this one you don't have uh, uh, t, right, time. And suppose that you're reading a problem statement or whatever problem that you have in front of you, you don't have the time interval of that journey with you, so you can use this equation, for example, right? And so that's why these are the all 4 possible equations of motion that you can have for a constant acceleration motion, constant accelerated motion. Okay, so let's go to the next page. Okay, let's do some problems, right? I think it would have been better if I wrote down the problems freehand, but we'll see. Suppose that you have a ball, right? And you raise it to some height. So let's say that this is my ground, and then suppose you raise it to a height of 20 meters, right? And you release it, and it falls, of course, with some velocity v. So what I'm saying is initially this ball is at rest, right? So this implies that the initial velocity is 0, right? Now it is released from rest from a height of 20 meters. We'll assume air resistance to be negligible, and then we'll compute some things. So this is my ground, and let me also, while we are at it, clarify what do we mean when we say negligible air resistance. I mean, in most of your problems, you just get rid of the air resistance and you solve all your problems. Sometimes we don't really know what it means when we say that the air resistance is negligible. What is air resistance? Any idea? Just take a guess.
Sir, opposing force.
An opposing force, right? But so where does it come from? I mean, the ball is falling in air, right? Is there nothing is there? Where is this force, resistive
Sir,
force
in
coming from?
opposite direction.
Sorry?
Sir, free fall
Again?
की opposite direction में.
Yeah, so what my question is basically where does this friction comes from? Like, why is it there? We usually, okay, let me frame it this way. We know that suppose this is a table, and I have an object on the table, and I move this object to any direction. Then because of the contact between the table and this object, there is some friction in the opposite direction. And why is that there? Because both these objects, they're not completely smooth. There are some cracks and a lot of other things that are in these. When you look at them, when you zoom in, what you see is that there are some cracks in table. So something like this is the table, and the object that I'm sliding on it really is also, it has some cracks in it. And when these cracks join together, so they fall into each other, and that's where the friction is coming from. So that is what is resisting the motion, right? So that's your friction, right? But in this example, where is that friction? I mean, is there any, because the ball is falling through air, so where is the friction coming from? Any guess? No idea?
No, sir, no idea.
Okay, so well, it is coming from the fact that air is not nothing, right? Air is a lot of things, and when you get down to the subatomic level, air is just molecules, right? So really what you have here is, let me use another color. You have a lot of, so I'm not going to draw all of them obviously, but you have a lot of air molecules that are surrounding this ball, right? We'll also, when we get to dynamics and all, we'll talk about pressure, and that's where I'll also tell you where does the atmospheric pressure comes from. It comes from the same thing, by the way. So what happens is when this ball is falling through air, it is colliding, it is hitting these air molecules. And when it does that, it transfers some of its energy to these molecules, right? And therefore it slows down. And that is air resistance, right? So it's colliding with these molecules, and these molecules are resisting, providing that not necessary, but providing that resistive force to this ball. And so it slows down. So well, that was just an idea of air resistance. I'll get rid of these air molecules now, because again, in our problem statement, we are saying that air resistance is negligible. So we don't have to worry about a force in this case, right? A resistive force in the opposite direction. Okay, so well, with this statement at hand, let's calculate some of the things. The first thing we'll compute is the time that it will take to reach the ground, right? So the first thing is time to reach ground. The second thing that we'll compute is with what velocity does the ball hits the ground? So what is the ball's velocity as soon as it hits the ground, right? So the velocity just before it hits. Right. So, okay. So I would like you to help me. How do I solve this problem? Again, I'll restate what we have. We have a ball that is raised to a height of 20 meters, and it is held there. So it's at rest, which means initial velocity is 0. And then it's released. So of course you would expect it to gain some velocity because there is some acceleration in the downwards direction due to gravity. It falls, right? It's a free fall. So it falls with some velocity v. How long before it hits the ground? How will we compute that time? So again, what we'll do is we'll write down some of the things that we have. We have u is 0. We have the displacement that it's covering as 20 meters. We have the acceleration, which is due to gravity, which is 9.81 meters per second squared. Okay, so are these variables enough to find time? Time taken to cover. So whatever time that whatever equation that you're going to use, the time that you're going to find will correspond to this displacement. So if I'm taking 20 meters as the displacement, that is the displacement to reach the ground, right? So it would have covered 20 meters to reach the ground. If I use some other value of displacement, then that would give me time taken to cover that amount of displacement, right? So these quantities are linked in that way. Okay, so yeah, someone was saying something. How will we find this time?
Sir, S is equal to UT plus half AT squared.
UT plus half AT squared. Right. So yeah. Now let's see. We want t, right? Before this equation is really, it might be difficult to factor out t. Well, it's not really difficult, but you see that u is 0, so this term will really become 0 because 0 multiplied by anything is just 0. And then you are left with half AT squared. So the equation is S equals half AT squared. So sometimes they ask you to as in memorize this thing that for whenever a ball is released from rest, then you use s equals half at squared. If it is released with some velocity, then you use s equals ut plus half at squared. But I would recommend not to go with that. Just understand the physics of the situation at hand, and then use the most general form of equation and then put in the values in that equation and see what is really happening, right? So this is the equation that I have, and this gives me t as 2 s over a. Is that right? 2s over a square root, right? So this would be just 2 times 20 over 9.81. And this would give you about 2 seconds, 2.02 seconds. So this means to cover a displacement of 20 meters under the effect of the gravity, that's what free fall means. If it's on Earth, then the gravitational constant, the acceleration due to gravity is 9.81, and the time taken to reach the ground is 2.02 seconds. Okay, now let's find the velocity just before it hits the ground. So now let's see. We have v. We want v. We have u. We have s. We have t. We have a as well, right? And we want v. So how can I find this final velocity just before it is about to hit the ground? So when they say that it is just before it is about to hit the ground, that means it would have covered this displacement of 20 meters, right? And just as it covers this displacement of 20 meters, it will hit the ground. So we want the velocity at that instant, right? So that would correspond to the either the total, well, both really, the total time taken to cover all of that displacement and the displacement itself, 20 meters, right? So the point is that even if I did not have this time, I could still figure out this value for v, or I could use an equation that involves time and figure it out as well. Suppose I don't have the value of t, how can I compute this final velocity?
V squared is equals to u squared plus 2as.
Exactly. Yes. So it would be v squared minus u squared is equal to 2as. And then just rearrange this so you get v squared as 2as because u is 0. And then you have all these values. So v is just the square root of 2 times 9.81 times 20 meters. This gives you 19.8 meters per second. Right. So any questions from this thing?
No, sir, no questions.
All right.
सर हम कभी कभी
Yeah.
ग्रेविटी माइनस में लेते हैं तो वो क्यों लेते हैं?
The value for gravity you're asking?
Yes, sir.
जी, ठीक है. So yeah. Okay, so I'll explain a bit. So let's not do another problem. I'll explain that first. So okay, so why we do that? Okay, suppose that you're standing on the ground, right? And well, not on the ground, sorry, on some cliff, right? And then there is ground over here, this thing. So suppose you're on this cliff, maybe you don't know that there is ground below, or even actually when you're standing in your suppose that you live on a second floor or third floor, ground, where is ground? That is completely relative, right? It is relative. As you might say that the ground is where I'm standing. So I'm standing at third floor, but maybe I'm looking out at the balcony and someone is standing outside below, and for him, the ground is where he's standing. So there is a difference in height between these two grounds. So what we call ground is really relative. So this person might say that this is ground, and so he will say that S over here is 0, or the height over here is 0. But then this person who stands over here, he'll say, no, the other person is at some height. Suppose it is, I'll just say S equals not equal to 0, as in there is some value for this height, right? So it is completely relative. Now, this thing, why gravity, sometimes we take gravity as negative. Well, it is all, even in this example that we did, gravity, we could have taken it negative, but then you would change your velocities as well. And what do I mean by that? I'll tell you. So what you do is, this person, you replace this person with a coordinate system. Because of course, this person is going to carry a coordinate system, X, Y, right? So it is really these coordinates, because what we are talking about for this person, we are not talking about this person physically, really. We're just talking about numbers for this person. How much time he is going to take, how much distance he's covering, what is the velocity of this person. So we don't care about the person in general at all. We just care about the numbers. And all these numbers can be shown visually on a graph. And the idea of graph just comes from this coordinate system. So the person really has a coordinate system. So for this person, if the coordinate system is set up over here as this, so I'll use some other color, this thing. So this is the coordinate system set for the person. Over here, for this person, he sees everything at this line origin as 0. Whatever is below this line, for this person, it will be negative. And whatever is above this line will be positive. Similarly, whatever is in front of him over here will be positive, and whatever is in back will be negative. Now, if I come back to the problem that we had, I'll draw it over here. Let me just change the color. Okay, so we had this problem. We had this ball. Let me draw it again. And it was falling to the ground over here. Okay, so it is again, it is covering some displacement. When it is falling down, the ball also carries a coordinate system. So I can replace this ball with a coordinate system. And this idea of coordinate systems is very important because it helps you keep track of your signs, right? So this is the coordinate system for both, which means, again, whatever is down is negative. Over here we have 0, and here positive. Similarly over here. Now, if the ball is falling downwards, its velocity, you would naturally, because the velocity will be where? It will be in this direction, right? So you'd naturally expect the velocity to be a negative number, less than 0. So the velocity is a negative number. Exactly, and for the same reason, G is also downwards, right? So G is minus 9.81. Now, why is that? Because the coordinate system that I defined was like this, at the ball. So I said my coordinate system is at the ball. Okay, using all of this, if I did the above calculation, suppose I wanted to compute this velocity or whatever, you would correspondingly change your values for velocity and displacement in the equation as well. So what I mean by that is, again, this displacement is 20 meters, but You see, it is downwards, 20 meters downwards. So again, it should carry a negative signature with it. Now let's compute the velocity. V squared minus u squared is equal to 2as. So v squared is just 2as. Now v squared is 2 times minus 9.81 times minus 20 meters. And then this would still give you the value for v as 19.8 meters per second. So it depends what coordinate system, where am I defining the coordinate system? In this problem, when we did it initially, our coordinate system was at the ground. Right? So this was our coordinate system. So that is why above this thing, the height was 20. So it was above, so it was positive. Right? So and gravity also lies above the ground for the ball. It lies in this region. Right? And hence it was again positive. So that was actually a very important question. I was going to get to this idea of coordinate systems as well, but I think it was good that we got to know about it before solving any more problems. So now this idea will be helpful when we do other problems as well. So is that clear?
Yes, sir. Thank you.
Okay. All right. So let me see. We have 2 minutes remaining. Okay. So there is another problem. Let's see. I doubt we would be able to finish it, but let's at least define the problem, right? And let me change back. Okay, so before I do this problem, what is today? Today is Tuesday, right? On Friday, you will, I'm just informing beforehand, you will have a quiz on kinematics, right? So whatever we would have covered up until Friday will be a part of the quiz. Don't worry about the quizzes again. I don't know if I mentioned this before. I guess let's devote this time to this discussion and we'll continue this problem in the next class. Don't worry about the quizzes. Again, of course, I told you it's an open book and I'm not going to, I'll not be seeing that you're cheating or not. So try to do it on your own. And if you really require, then just use your books to try to understand what you need to solve that problem and understand that concept, and then not Google your questions and just copy paste, because that is just harming you, right? So there is no point in cheating. Just it's for your own good. So hopefully I'm sure that there will be no such thing as copying from Google or anything, right? Okay, so I guess that's it. Is there any question regarding the quiz or the class or anything?
No, sir.
No, sir, no question.
All right. Okay. So we'll continue from this thing in the next class. All right.